Hello all. So in the last lesson we have seen what is the shape of the earth, right? So what is the shape of the earth? Earth is a oblate, spheroid or geoid, right? Now we see so many places on the earth. Now how to locate positions on the earth? How to locate positions on the earth is what we are going to see in this lesson. How to locate positions on the earth is with the help of different lines called latitudes and longitudes, right? Latitudes and longitudes. So this network of latitudes and longitudes is known as Earth's grid. Earth's grid. We know grids, right? Normal graph paper, we know a normal grid. So this becomes the y-axis and this becomes the x-axis, right? On a normal graph sheet, how do we locate the positions? How do we locate a place? Suppose this is the place, starting from 0. Suppose this is the place. This place is 2 points on the x-axis and 2 points on the y-axis. We name it as 2, 2. Right? We name it as 2, 2. Similarly, for the earth also, it is all the places are an intersection of the latitudes and longitudes. Even for the earth, even on the earth, so we have parallels of latitudes and meridians of longitude. So places will be intersection of parallels of latitude and meridians of longitude, right? If you see this place is an intersection of this longitude and this latitude, right? So this is known as the Earth's grid. Earth's grid. Right. So when we see the earth is divided into 4 hemispheres. The earth is divided into 4 hemispheres, right? The northern hemisphere and southern hemisphere. The northern hemisphere and southern hemisphere as divided by the equator. As divided by the equator. The eastern hemisphere and western hemisphere as divided by the prime meridian. As divided by the prime meridian. So we have 4 hemispheres in all. We have 4 hemispheres in all. Taking equator as the standard, we have 2 hemispheres, the northern and southern hemispheres. Taking prime meridian as the standard, we have 2 hemispheres, the western and eastern hemispheres. And what helps us to locate the places on the map is the directions. The directions. So all of us know the 4 directions: the north, south, east and west directions. So these are known as the cardinal directions. These are known as cardinal directions. Northeast, southeast, southwest and northwest. These are known as intermediate directions. Intermediate directions. Right? These are for more easy understanding or more proper understanding. Okay? Next, coming to the Earth's grid system. Let us know what is the Earth's grid system. Now, Earth's grid system is made up of a network of latitudes and longitudes. We have seen Earth's grid system is made up of a network of latitudes and longitudes. Now, let us see what are the latitudes. So, this is the equator. This is the equator. All lines which are drawn parallel to the equator. All lines, all imaginary lines. All imaginary lines which are drawn parallel to the equator are known as parallels of latitude. And these parallels of latitude, these parallels are 90 in the north and 90 in the south. 90 in the north and 90 in the south. So, total parallels of latitude are 90 plus 90 plus 1 equator. So, 181 parallels of latitude. 90 in the north, 90 in the south and 1 equator. So, totally 181 parallels of latitude. Right? Why only 90? Why only 90? See here, this is 90 degree north. This is 90 degree south. There is no highest point. There is no highest point than 90 degree. There is no highest point which can be reached than the 90 degree. Right? See on the protractor, mathematically we can see on the protractor, right? So 90 degrees is the highest point which is reached. Starting from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 90. After 90 again it starts coming down till 180. Right? So what is the highest point which is reached is 90 degrees. Right? The highest point which can be reached is the 90 degree angle. So 90 degree, 90 parallels of latitude in the northern side and 90 parallels of latitude in the southern side. And all these parallels of latitude are equidistant from each other. All these parallels of latitude are equidistant from each other. Right? And each parallel of latitude is at a distance of 1 degree. The distance of parallel of latitude, each parallel of latitude is 1 degree, and distance between each parallel of latitude, distance between each consecutive parallel of latitude, one by one, each consecutive parallel of latitude is 111 kilometers. Why only 111 kilometers approximately? It's only approximate figure. Why only 111 kilometers approximately means, see, the circumference of the earth is 40,000 kilometers approximately. So this approximate figure of 40,000 kilometers, when it is divided by 360 degrees, because the total angle which is divided is 360. So when it is divided, it gives a distance of 111 kilometers. 111 kilometers. So the distance between each parallel of latitude is 111 kilometers. The equator is considered to be the largest line or the largest latitude as it is going towards the poles. The distance of the parallels of latitude, keeps on decreasing. As it is coming towards the poles, it becomes a point. Total. So, equator is considered to be the greatest circle. Or great circle, and all the other parallels of latitude are considered to be small circles. All other parallels of latitude are considered to be small circles. Right? Next, what are the 5 main parallels of latitude? Coming to the 5 main parallels of latitude, the first main parallel of latitude is the 0 degree parallel, and that is the equator. Coming to the next one, 23.5 degree north, Tropic of Cancer. Next is 23.5 degrees south, Tropic of Capricorn. 66.5 degree north, Arctic Circle. 66.5 degree south, Antarctic Circle. And the last one is, these are the 5 main parallels of latitude, and 90 degree north and 90 degree south are not considered to be parallels of latitude since their distance is 0. These are points, the distance is 0. They are not considered to be parallels of latitude. Right? So, these are the 5 main important parallels of latitude. 0 degree, on the 0 degree latitude, we see the vertical rays of the sun all throughout the year. From 0 to 23.5 degree. We see the vertical rays of the sun all throughout the year. So, this is termed to be the torrid zone. From 23.5 degree, that is 23.5 degree north to 66.5 degree north and 23.5 degree south to 66.5 degree south. That is Tropic of Cancer to Arctic Circle and Tropic of Capricorn till Antarctic Circle. This area is termed to be the temperate zone. This area is termed to be the temperate zone. So here in the temperate zone, the rays of the sun are oblique. The rays of the sun are oblique. So here we see moderate temperatures and moderate precipitation. Coming to the next zone, 66.5 degree to 90 degree north and 66.5 degree to 90 degree south. This is termed to be the frigid zone. This is termed to be the frigid zone. So here in the frigid zone, the rays of the sun are more slanting. The rays of the sun are more slanting. So here we do not see any kind of temperatures. I mean very less temperatures when compared to the torrid and temperate zones. Now let us see what is the importance of latitudes. Now we have seen that these 5 latitudes, they divide the earth into 3 heat zones. So this is one main importance. 3 heat zones: torrid, temperate and frigid zone. So on the basis of latitude only we can know the temperature of a place. So if latitude is increasing, temperature keeps on decreasing. If latitude is increasing, temperature keeps on decreasing. So latitude is increasing, it goes towards 90 degrees north. Here also latitude is increasing, it goes towards 90 degrees south. So basically temperature will be decreasing, right? And latitude along with the help of longitudes. Latitude along with the help of longitudes helps us to know the position of a place. So these are the 2 main importance of latitudes. On the basis of the position of a place only we can know the climatic types, we can know the natural vegetation, soil types, so many things we will be knowing. This equator, it divides the earth into 2 equal halves. This equator, it divides the earth into 2 equal halves. All the other parallels of latitude are not great circles. They go on decreasing their size, right? But meridians of longitude are not like that. We will discuss it later. And if a traveler is traveling through the great circle, he saves a lot of fuel and time, right? So these are some importance of latitudes. Next we come to the concept of longitudes. So in the concept of longitudes, longitudes are semicircles which are drawn from the North Pole to the South Pole. So this is the North Pole and this is the South Pole. The semicircles which are drawn from North Pole to the South Pole. In fact, there are full circles which are drawn to the either side. If you see, this will be the full circle which is drawn on the. So this is the full circle which is drawn onto the earth. So this is the full longitude which is drawn. So one side, if you are seeing, it seems to be a semicircle. The other side again a semicircle. If you are seeing, it is a full circle. So all the lines will be passing through the North Pole and South Pole. The distance between, the maximum distance between two longitudes is highest at the equator, that is 111 kilometers. As you are going towards the poles, it decreases. The distance between the longitude, it keeps on decreasing as you are going towards the poles. As we are near to the equator, it keeps on increasing as much as 111 kilometers. Right? And how many longitudes do we have in all? How many latitudes do we have in all is 181. But longitudes is number of longitudes is how many angles we have in a full circle. That is 360. 360. For a full angle, we have 360 degrees. So that 360 degrees, that many angles, that many longitudes we will be having. Right? So one side we will be having 180, the other side we will be having 180. Right? Starting from the prime meridian, one side 180, the other side 180 longitudes we will be having. Now imagine, so this is the 0 degree longitude. This is the 0 degree longitude. We will be drawing as many as 179. What happens? This way we will be having 180, right? This way we will be having 180. So after going this side, the 180th one, the 180th east side we are going, 180th east, and this side if we are going 180 degree west. So both will be meeting at the same point. Both will be meeting at the same point. So 180 degree east and 180 degree west are one and the same line. Right? 180 degree east and 180 degree west are one and the same line. Right? And that is treated to be our international date line. Okay, one side is our prime meridian and the other side is the international date line. Now let's see the importance of longitude. The first importance of longitude, as in the case of latitude only, with the help of latitude we can fix the position of a place. Then what else is, we can know the time of a place with the help of longitude. We can know the time of a place with the help of longitude. And moreover, this prime meridian, it divides the earth into, as in case of equator divides the earth into two equal halves. Here also, this prime meridian, it divides the earth into two equal halves, the eastern and western hemispheres. Now let us know about the great circle roots. The shortest distance between any 2 points on the earth's surface is known as arc of great circle. Why people opt for this arc of great circle? I mean, great circle roots is one for saving the fuel, second one saving the time, right? And in the northern part of northern poles, normally near the Antarctic region, generally these great circle routes are adapted to stop the accidents, right? Now let us know the calculation of longitude and time. So all of us know run behind time today. How did we calculate? How did we start time? From where did we start time? We do not know. We started calculating back also, 6 BC, 7 BC. We started calculating the time travel also, right? But from where did we start this? In 1884, all the countries, they have decided by an international agreement that they will be following the time at the Royal Observatory at the Greenwich. So from the noon at 0 degree, they started calculating the time. Okay, they started calculating the time, and all the countries which are ahead, that means which are on the east, will be going ahead, and all the countries which are on the west will be going behind the time, right? Which are on the west will be going behind the time of the Greenwich Mean Time. Right? So at 0 degree, when it is 12 noon, from there they have agreed that okay, this is 12 noon, from here we start calculating our time. Okay? Then how to calculate the time? At what rate? At what rate should we calculate the time? Right. So we have 24 hours for each rotation, right? You have 24 hours for each rotation. And for each rotation, the total angle which is covered is 360 degrees. So this 24 hours, if we are, for 1 degree, how much? Then for 1 degree, how much? Just a unitary method calculation. 360 divided by 24. So when you simplify it, for every 15 degrees you get 1 hour. Still more simplifying, this 15 degrees for 1 hour. This 1 hour is 60 minutes. 15 degrees for 60 minutes. So 15 ones and fours. 1 degree for 4 minutes. One degree for 4 minutes. This is the rate of change for every longitude. So these are number of longitudes. So for every longitude we have a change of 4 minutes. So you are changing the longitude, we are changing 4 minutes. This is the longitude, right? We are changing the longitude, we will be changing 4 minutes. East side if you are going, you will be adding. If you are going west side, you will be subtracting. Minus 4. Minus 4. Right? So with the help of this, we can know the local time. With the help of this, we can know the local time of the place. Suppose my place is 20 degrees east. Now my time will be 20 into 4, that is 80 minutes ahead of 80 minutes ahead of the Greenwich Mean Time. 80 minutes ahead of the Greenwich Mean Time. Like this we can know the local time of a place. But in one country you have so many places with so many latitudes, so many longitudes, right? In one country we have so many places with so many longitudes. My neighboring place is there. Like Hyderabad is there. Hyderabad's longitude is not as my place longitude. So time from Guntur to Hyderabad will be different. But normally if we check the time here, the same time what we have here in our watch will be the same in Hyderabad's watch, will be the same in Delhi's watch, will be the same in Bengaluru's watch. Right? So why all this confusion is not there means we follow one standard time. We follow one standard time for the country. Suppose the country is small, we follow only one standard time. The country is having large longitudinal extent, we will be having some more time zones, so that we will be having number of time zones to be calculated. For India we are having only one standard time. Now how to calculate the standard time of that country? How to calculate the standard time of India means we generally calculate the midpoint of the extreme longitudes, the east extreme longitude and the west extreme longitude. So here the east extreme longitude is 68 degrees east and 97 degrees east approximately. So what we do, we calculate the midpoint for these two. 97 plus 68 is 5. 165. So divided by 2, when we have to get the midpoint, divided by 2 is 82.5 degree east. Approximately, this is all approximate degree east. So this is our standard meridian. Now to calculate our standard time, what we need to do? We got this for every 15 degrees 1 hour, right? For every 15 degrees 1 hour. Now what I am doing is, I am writing like 75 degrees plus 7.5. So 75 is 15 into 5, 15 degrees into 5 plus 15 degrees into half. 15 degrees is nothing but 1 hour, right? So 1 hour into 5 plus 1 hour into half. So total is 5.5 hours. 5.5 hours is our standard time. 5.5 hours is our standard time, and since we are on the eastern side, 5.5 hours plus. 5.5 hours plus. And the next one is the international dateline. So we have seen that just opposite of the prime meridian, the opposite line is the 180 degree east or 180 degree west meridian, which is also known as international dateline. Why people have opted this international dateline is, suppose a person is traveling from the east towards this international dateline, he will be gaining one day, isn't it? He will be gaining one day because he will be traveling towards this side, and 180 into 4 minutes will give you 12 hours. Suppose if he is traveling towards the western side to the same point, 180 degree west, he will be losing 12 hours. So if he is traveling to the same point, if he is traveling from the east, he is gaining one day. If he is traveling from the west, he is losing one day. So to avoid this kind of confusion, people came up with one solution, that is the international dateline. And this 180 degree east or west meridian, it passes through the Pacific Ocean, and it is seen that there is no landmass from where it is passing, because if there is a landmass, in the same landmass we will be having two different dates. So that is why this international dateline is a zigzag line. It's a zigzag line, right? And the last topic what we are going to see is the time zones. So we have seen that the 24 hours are divided by 360 longitudes. It gives 15 degrees for every 1 hour, right? It gives 15 degrees for every 1 hour. That is why the total world is divided into 24 time zones. 24 time zones on the basis of this 15 degree breakup. So on the basis of for every 1 hour we will be having one time zone. For every 1 hour we will be having one time zone. So how many time zones we will be having? Means 24 time zones we will be having. If the longitudinal extent is big, then we will be having more time zones, more number of time zones. But if the longitudinal extent is small, India is a small country and we are having only one time zone. But for a big country, country like Canada or North America, Russia, which are having very large longitudinal extent, those countries will be having large longitudinal extent, and those countries they will be having more than one time zone. Three questions for recap. What is the difference between latitude and longitude, and how is the time calculated for every longitude, and what are time zones? So Just a small recap and hope the lesson is understood. Thank you.